Hello everyone and welcome to the 4th GCSE Chemistry lesson. Here we go. So today our learning question is, can I describe the 3 states of matter? So they're the 3 states that all matter can exist on in Earth. What we're going to do first of all is just a quick bit of revision about some of the periodic table stuff that we did a couple of weeks ago. Okay, so just to make sure that that we don't forget that learning. Okay, so if you can make sure that you have with you a pen or a pencil and a piece of paper or a notepad. If you don't have those, then just pause the video now and go to get them, and make sure you're working somewhere with some space and some quiet if you can. Excellent, well done. So the learning question is, can I describe the 3 states of matter? If you could write that down at the top of your page, that would be brilliant. And the do it now, it's a short do it now. It's just 3 questions about the learning that we did about the periodic table a couple of weeks ago. So number 1, where are elements with similar properties placed in the periodic table? Number 2, where do the atomic numbers increase by 1 each time in the periodic table? And number 3, what is found in the shells of an atom? So if you can pause the video and try and answer those questions. Brilliant, well done. So give yourself a tick for ones you got right. And if you didn't get them, don't panic. Just correct them. That'll be really useful for learning in the future. So number 1, where are elements with similar properties placed in the periodic table? They're placed in groups, so the columns going down. Where do the atomic numbers increase by 1 each time? Along the period, so that's going across. So as you move along the periods, if you move along the period in the periodic table, along the row, then the atomic number, remember that's the number of protons in each atom, the atomic number will increase by 1 each time. And question 3, what is found in the shells of an atom? It's electrons. Remember, an atom has got those, we draw them as circles, don't we, around the outside of the atom. And inside those shells, that's where the electrons are placed. Brilliant, well done. So the next thing I've got for you is a paragraph to write out and insert the correct words from this little list of words at the bottom there. All right, so if you could pause the video now and do that, and then we'll talk through it together. Well done. Fantastic. Okay. So we'll go through it together, and feel free to, if you want to, you can shout out the answers. The atomic number of an element is equal to the number of, that will be protons. Yeah, atomic number is equal to the number of protons, so protons will go there. Atoms with no charge have the same number of protons and electrons. Remember, it's that seesaw idea. So the number of protons is positive, the number of electrons is negative. So when an atom is neutral, those protons and electrons are the same. So the same number of protons and electrons, which are found in shells. The first shell can hold up to 2 electrons. The second shell can hold 8 electrons. And the third shell can hold 8 electrons. Yeah, so first shell is 2, second and third and subsequent shells are 8. The number of electrons in the outer shell goes there, is equal to the group number the element is found in. So the number of electrons in that outer shell is equal to, remember those columns are called groups, is equal to the group number that the element is found in. Well done. So I hope you ticked those if you got them right. And this is the last part of our elements and periodic table revision. Okay, and then we're going to move on to our new topic of states of matter. So if you can write 1 to 5 on your piece of paper or your notepad, and then answer these questions, please. So pause the video now and do that. Excellent, well done. So nitrogen has 7 electrons. Write out its electronic configuration. Okay, remember we write out the numbers and then we put either full stops or commas between them. So it would be 2, because remember the first shell can only hold up to 2, and then 5. Okay, so they need to add up to 7 because nitrogen has 7 electrons. So it will be 2 in the first shell, 5 in the second shell, and that's how we write it there. Okay, so that's question number 1. Question number 2, the group number of an element is equal to the number of electrons in its outer shell. So remember that outer shell is equal to the group number, so whichever column the element is in the periodic table. Carbon is in group 4. How many electrons are in its outer shell? 4. Chlorine's atomic number is 17. Write out its electronic configuration. So remember, these need to add up to 17. So 2 can go in the first shell, 8 in the second, that adds up to 10. And then in that last shell, that outer shell, we can have 7. And sodium has 11 electrons. Draw its arrangement. Draw its electrons using X's to represent the electrons. So here we go. So 2 in the first shell of sodium, 8 here in the second shell, and we do sort of usually traditionally draw them in pairs like that. And then the outermost shell would have the last 1, so it can add up to 11. Well done. So pause now if you need to just mark those for a moment and give yourself a mark out of 5. If you didn't score too well, don't panic. What you can do is you can use BBC Bite Size to go and revise atomic number in the periodic table and electronic configuration, and then maybe take the quiz again, see if you can get a better mark. All right. So moving on then to states of matter. There are 3, I'm sure you know this bit already, okay, because we did this at Key Stage 3. So there are 3 states of matter. Solid here, so that's ice cubes representing solid. Liquid here, that's water representing liquid, and gas. There's some steam representing gas there. What I would like you to do is try and name these conversions between states of matter. So what is it called when a solid changes into a liquid? And what's it called when a liquid changes into a gas? And so on. So if you could pause the video now and try and write down those words, that would be great. Excellent, well done. So solid into liquid is melting, liquid into gas is evaporation or boiling, liquid into solid, freezing, and gas into liquid is condensation. So you often see condensation on your windows on a really cold day. So that's where the gas that the water vapor that you've been breathing out in the room or in the car, it condenses on the cold window and it turns into a liquid. Okay, so thinking a bit, what we're going to do now is do some thinking about solids, liquids and gases. So our thinking questions are, can you squash a balloon? Okay, so have a think about that now. It's a shame I should have had a balloon here to show you. I've actually got some for my daughter's birthday in a drawer downstairs. So if I'd have thought, I could have got one to show you. But yeah, you can. If you squeeze a balloon, not too hard, otherwise it'll pop, which always makes me jump. But if you squeeze a balloon, you can compress that balloon a bit, so you can squash it. So in a moment, we're going to have a think why that is in terms of the particles, so particle theory, particles and gases, why it is that we can squash them. What is squashed in a water pistol? So when you fire a water pistol, inside you are trying to compress that water. So does this mean that water can be compressed? Well, if you think what happens when you do squeeze a water pistol, there's pressure inside it, which means that the water squirts out. So actually you can't really compress that. That's why the water will squirt out of it. And the last question to think about, can a solid be compressed or squashed? It can't. If you try and compress, so this little table that my laptop's on, I can't compress it. I can try and squeeze it, but it won't compress. So what does that mean about the particles inside a solid? All right. So I'm going to hand over very quickly, if I can. to this gentleman, who you might have seen before in some revision videos. And he's going to explain solids, liquids and gases a bit more. And what I'll do is I'll stop the video at any point and explain further. All right, so before we start the video, what I would like you to do is just draw out these 3 diagrams of a solid, a liquid and a gas, the particles in a solid, a liquid and a gas. And we call these particle diagrams. So if you can pause the video now and just draw those out. So then you will have room underneath them to write some notes. Well done.
As you can see, the particles are arranged differently in these 3 states of matter, and you need to be able to describe how they're arranged. We're going to start by looking at the features of solids and then explain these features using particle theory. Firstly, solids are extremely hard to compress, in other words, squeeze. That's because the particles in a solid are packed together in a regular pattern with almost no spaces between the particles.
Okay, so as he just said, solids are extremely difficult to compress. So you can see here this regular structure where all the particles are touching and there's no space in between them.
Secondly, solids have a fixed shape and they cannot flow from place to place. That's because in a solid, the particles can vibrate, but they cannot move from place to place.
Just go back one sec. So in a solid, the particles don't have very much energy. They've got the lowest energy in all the states of matter. So they're not moving around much, they're just vibrating. Okay, so they can't move from place to place, they can only vibrate in a fixed position.
Move from place to place. Okay, let's look now at liquids. Just like solids, liquids are extremely hard to compress. And again, that's because the particles are close together, with not many spaces between them. Unlike solids, liquids take the shape of their container and they flow from place to place. That's because the particles in a liquid can move.
Okay, so looking here at the particles in a liquid, they are arranged differently. So what we can notice that's different to the arrangement of particles in a solid is that they're not in a fixed shape. And that means that they're free to move around. They can slide over each other. And that's why we can pour a liquid.
Okay, we're going to look now at gases. Firstly, gases are extremely easy to compress. That's because the particles in gases are widely spaced. Secondly, gases spread out and fill the space of their container. And that's because the particles in a gas move quickly and randomly.
Okay, so in terms of the energy that a gas has, gases have the highest amount of energy of all the states of matter. And that means that the particles are moving around really quickly and randomly.
Okay, now we can change the state of a substance by putting in or taking out energy. So we're going to look at that now. I'm showing you here a solid changing state to a liquid. This is called melting, and this takes place at the melting point. Now, as you can see, the particles in a liquid are moving around, so they've got more kinetic energy than the particles in a solid. This means that we've got to put energy in to convert a solid into a liquid. This energy is needed to break the forces of attraction between the particles in the solid. Once these forces are broken, the particles can now move around. In other words...
Okay, so when you melt a solid into a liquid, you are giving these particles more energy. And what that does is it means that they are then able to move around each other more. So they come out of this, the bonds break, they come out of this fixed regular structure over here on the left, and they become a much more random structure, like the structure in a liquid. So if you were to leave an ice lolly out in the sunshine, the sun's energy would be transferred into the ice lolly. It would break the bond so that particles could move around more. The particles would have more kinetic energy, so it would melt the ice lolly into a liquid, into a puddle on your patio floor.
Change the solid into a liquid. Now, there's one really important fact that you need to understand. The stronger the forces of attraction between the particles, the more energy we've got to put in to break them, and the higher the melting point. I'm showing you here a wax candle. Now, candle wax is a solid with a relatively low melting point, and that's because the forces of attraction between the particles are relatively weak, so they're fairly easy to break. This shows sodium chloride. In this case, the forces of attraction between the particles are very strong, so sodium chloride has a very high melting point.
Okay, so that's a nice place to just pause the video, because do you remember we looked at sodium chloride when we were looking at ionic bonding, and sodium chloride has that regular ionic lattice structure, doesn't it, with the ions that are attracted to each other, those oppositely charged ions, and that means it has really strong forces of attraction between all the particles in it, and that's why it has a very, very high melting point. Okay, so if I just take you back to our PowerPoint. Okay, well done for sitting through that video, and hopefully you made some notes. If you didn't, or if you struggled to kind of write notes while you were watching it, feel free to just rewind this video and watch it again so that you can take some notes. So now we've got a series of true or false questions. So all we have to do is these true or false questions, and then there's a 6-mark question at the end, which you can complete on Shobi if you want to. Okay, so we're nearly there. We've done really, really well. So what I'd like you to do is write 1 to 5 in your notebook or on your piece of paper, and see if you can write true or false for each of these questions. So pause the video now and do that. Brilliant, well done. So the particles in a substance that have the most energy when they are in a solid state of matter. That's false, isn't it? We know from what I've just said and from watching the video that particles in a gas have the most energy. That's why they're moving around so quickly. Number 2, the particles in a liquid can move quickly in all directions. That's false. They can move, but they can only slide over each other, can't they? Because they are still touching. They can't move around lots like they can in a gas. Number 3, the particles in a gas can move quickly in all directions. That's true. Number 4, the particles in a solid can move around each other. That is false. The particles in a solid are just in that regular lattice shape, aren't they? They can only vibrate against each other. And number 5, the particles in a liquid vibrate in a fixed position. That's also false. The particles in a liquid, they're not in a fixed position. They're able to slide over each other. All right, well done. So give yourself a mark. If you've got a few wrong, maybe worth going back just to watch that video again. Well done. Okay, and finally, so we finished our lesson for today and we've got to this 6-mark question. And what I would like you to do, if possible, is answer this question on Shobi. So you just go to www.shobi.com. That's our class code there, ZKCJQ. So if you can answer this question on Shobi, and then myself or another science teacher will be able to give you some feedback for it, which would be really nice. And it's just lovely to see your answers because we all really miss you. So the question is, describe the arrangement and the movement of particles in each of the 3 states of matter. So that's kind of the first part of the question. And then explain what happens to the particles in a liquid during boiling. That's the second part of the question. Often 6-mark questions kind of have 2 parts to them like that. So you need to make sure that you write some points for that first part and some points for that second part. Okay, so if you don't have access to Shobi or you can't use Shobi, then just write it out on a piece of paper. That'd be brilliant. All right, so lovely talking to you. Hope you're all well. Have a lovely week. See you next time.